morning. I'm David McLeod. I'm a principal engineer at the CHPC. I'm also the leader of NICI's Cloud OpenStack, Cloud IST. That's Integrated Service Team. That's a group of people within NICI's that are working on cloud-related projects across CHPC, San Juan, and Derisa. Brings them together to coordinate cloud activities within NICI's and to discuss our future plans for how we want to be deploying our cloud environment. Today, I'm going to be giving you a bit of information on the history of cloud within NICI's, how we got to where we are, and talking about how that has affected the organization, how it's requiring us to do things a bit differently because of the nature of cloud. Some of it's structural, which is the easier side of things, but a lot of it is changing mindsets as to how we should be running a cloud service and how we should be operating within the organization, and some of the opportunities that is creating for us. And then I'll give you some information on the progress that we've made with our localized cloud platform, some of the things that are going to be coming in the future, and then to get input from the audience as to anything that you would like to see added to the NICI's cloud service. So starting with the history of cloud, it goes back to the CHPC all the way in 2011, which is quite a long way back, actually. What we initially were trying to do with cloud was just use it as a prototyping environment. We wanted to be able to create small environments where we could test out different hardware and software and then tear it down and replace it quite easily. During that time, there wasn't a very clear winner into the cloud wars. It was still very early days, and we chose OpenNebula at first because we were building a private cloud, essentially. OpenStack was like a couple months old at that point, I think. So it wasn't really on our radar too much at that point. And OpenNebula was good for what we were trying to do. But while we were experimenting with it, we realized that cloud infrastructure, it's a cluster, just a different type of cluster, and that there were components within the cloud environment that could be used to create a more modernized way of managing HPC infrastructure. So we started looking at the convergence of cloud and HPC, and we were shouted at and told, "You're making a mistake here. Cloud and HPC totally incompatible and never work. Performance overhead is too much. This is a very bad idea." Well, I guess they were wrong. What they didn't realize was that even if you don't do virtualization, there are components of cloud that are useful for managing HPC environments, and that the overhead and performance issues can also be resolved with time. During that period, it then started attracting attention from users that wanted the cloud platform, and by 2014, we realized that we should be looking at some kind of a public cloud proof of concept for the CHPC, so we deployed our first OpenStack environment. That was incredibly popular and almost immediately had to get put into a sort of semi-production state, and it existed for far longer than it should have been, but it proved the point. There was a demand from our users for cloud. The actual first production cloud service that was created within NICI's, although NICI's didn't exist at the time yet, was within Derisa. That was a Red Hat-based cloud platform, OpenStack cloud platform, that they were using to host their virtual machines and some of the virtual machines for their users. Then in 2020, the CHPC established its first cloud service. That is the one that you know today as Saboa, but it initially wasn't established as Saboa. It was established as a cloud service, specifically within NICI's to replace some of the VM hosting that we were doing and to replace what was being done within our proof of concept, so to speak, OpenStack Cloud. That was quite an interesting scenario because it had to get rushed into service to assist with the response to the COVID pandemic. The other important thing about that cloud is that it forms the technological base for what then became the NICI's cloud, and also, in a sense, becomes the localized cloud platform that we're working on. And then in 2021, we went about the process of starting to combine these cloud platforms to create a unified cloud service for NICI's instead of having separate cloud services for each unit within NICIS. That was something that we realized as soon as NICIS was created pretty quickly, that we were on a bit of a bad path. We had within the CHPC its production cloud service and a whole lot of other development and QA clouds in existence. DERISA had their production cloud service, and they were planning the procurement of a new cloud service. DERISA was even Sanrin was even starting to think about establishing a cloud service for their users. And the realization was quite simply that this was a bad idea. It was going to have competing services within NICIS. It was going to create a fractured environment. It was going to duplicate resources, both technological and human. It was going to increase overheads, increase costs. It was just a clearly bad way to go. So we needed to change structurally how we were delivering cloud within NICIS to create this unified service. So the future block there is where we want to get to, but you can't just go straight to the end. You have to go through some sort of transitional phase. So we started this process, and it's still ongoing, and it's going to take a while. But the first thing was to say, well, this DERISA cloud, it shouldn't be upgraded into a new version. Rather, let's take the users from the DERISA cloud and move them into the CHPC cloud, which won't be the CHPC cloud anymore. It'll be the NICIS cloud. It'll be co-managed and administered by both of those groups. And then also, let's take the budget that had been set aside for that DERISA cloud and use it to start upskilling staff within NICIS with regards to cloud services. Because there's another thing that cloud is forcing us to do, and that's to actually invest quite a lot more in skills. And the idea was then to build another zone of Saboa. We understood it would take a lot longer for us to do because of this upskilling process. But build another zone of Saboa using entirely NICIS staff with limited support from contractors, just to see if we could internalize those skills and start doing this on our own. And that comes to the part where we needed to start really looking at changing mindsets for how we were doing things within the organization. This combining of CHPC, Sanrin, and DERISA is a fairly recent thing, or it was when we started doing this cloud story. And it was actually one of, if not, I think it probably was, the first project that NICIS needed to deliver as a unit at the NICIS level, and not as a project within one of the individual groups within NICIS. That was quite a big mindset for us to change really. It required us to work much more closely interdepartmentally within NICIS. But it also gave us this opportunity to start sharing knowledge better within the organization. Instead of having these silos of knowledge and silos of knowledge generation, we were able to talk to each other across the boundaries, work together as a single team, share that knowledge, and start developing much more quickly with a larger team. So this move to cloud came with this realization that we need to be investing in skills a lot more than we had ever done before. In the past, we would typically within NICIS go on procurement to procure a service that we would then work with a contractor to support and deploy. And that became a bit of a problem, or the realization is that it's a bit of a problem for the cloud environment. And it comes down to this statement that clouds evolve. They do not begin or end and begin anew. As I mean, they don't have this very clear set of iterations that they go through. So I can give the example with an HPC cluster. The intention there is you buy a cluster, you run it for several years, you then retire it and replace it with something new. There's a very clear begin and end for that cluster. And within that period in which you are running that cluster, you want that environment to be as stable as possible. You want to make a platform that is constant, that your users can optimize for, really get to terms with, and use it fully for that period. So you see, and it's not a thing that's unique to the CHPC, but clusters are very static systems. They don't change much over the course of their lifetime. The joke is you turn them on, you run them for 4 years, and you turn them off and throw them away. But cloud, that's not good for cloud. It actually takes away some of the benefits of the cloud, and that is its flexibility. That's the thing that a cloud brings. with a cloud, you want to be able to make incremental changes over time without ever retiring it or disrupting it so massively that it's viewed as a new system to your users. So the example there is EC2. The 2 is not version 2, it's 2C's Elastic Compute Cloud. That system is 18 years old currently. And it still performs the same role. It's the virtual machine service within AWS. It still performs the same role. It's very different to what it was when it was first released, but it's still on the same, so to speak, version. It's the same thing. They haven't got EC2 version 2. That is the power of cloud. You are able to take something and evolve it over a long period of time. And that is something that we need to be applying more to the systems, our cloud systems, within NICIS. But if you were to do that, it becomes problematic, especially if you're doing it without strong skills in cloud within your organization, because that puts you with a very heavy dependence on contractors. And then you run into the situation where you want a cloud platform to be effectively indefinite. You can't have an evergreen contract. Legally, you can't do it, and just business-wise, you don't want to do it. You don't want to lock yourself into a vendor. So you can't really go down that route, and you can't really just rip out and replace your cloud platform every 4 years, because then you start defeating some of the points of running a cloud platform in the first place. You lose that flexibility that's so important. So the only solution around it that I can really see is that you start investing more within the skills within your organization, so that you are able to take the destiny of your cloud platform and put it into your organization's hands, so that you have at least some core competence within your organization to define a standard for what a cloud platform is, and then build that out on your own where you can, but where there are gaps, to then go to the market, to contractors, to partners, and work with them to fill in those gaps. So I'm not saying you kick out the partners and you do it on your own. I'm saying you work with them in a different way, such that you drive the direction as the organization and you have external partners coming in to support you where you need it. But you still need the basic skills within the organization to be able to define that platform and have a team in place that is able to support it, at least in its core services. So that was the primary mindset that needed to be changed within the CHPC, or NICIS rather. The problem here, which is also an opportunity, is that you are now investing a lot of skills in high demand areas, which means there's a cost associated with doing this. So we need to look beyond simply building a team of advanced experts in cloud. We need to look at what kind of opportunities we can get out of this as well. The first are just the obvious ones, right? In fact, they're all pretty obvious, really. But the first thing is that we need to be able to make proper usage of our cloud platform. Right now, for many reasons, our cloud platform is used and managed in quite a static way. As I said, you need a certain level of skill and internal know-how to be able to make these cloud platforms more flexible and more dynamic. By investing in those skills, we would be able to move away from treating this cloud platform as a simple hosting environment, start actually using more of the advanced features within cloud that allows us as a cloud operator to make more use of the limited resources that are available in the cloud, but also allows users to build better applications. You can say cloud-native applications that are more resilient, that can do things like dynamic scaling and actually take use of those features within the cloud environment. Instead of doing what is quite often now the case of statically saying, oh, this is a virtual machine for that region, and this is a virtual machine for that region, we're saying pool of virtual machines as load scales, scale the number of virtual machines, and handle that load. Those kind of things. So we need skills within the organization to teach users how to do that. Because within NICIS, a big part of what we are supposed to be doing is skills development within the community. But the other thing that is very important within the NICIS cloud environment is that if we have those skills, what we should be doing is looking at cloud not so much as another service within the basket of services that NICIS offers, but as a mechanism by which NICIS delivers its services. It could be used as a glue, so to speak. And in doing that, by taking the unique infrastructure that NICIS has within the country, delivering it through a cloud platform, we can then start to create a cloud service that can be differentiated from other cloud services that exist within the country. So we have AWS and Azure with local cloud data centers at the moment, their commercial offerings. But I think there's an opportunity if we can actually start integrating not only the technical infrastructure that NICIS has, but also the people, the domain experts from the variety of fields that NICIS has within its umbrella, and making those available to the community via these cloud platforms. So that's just the benefits with the NICIS. It allows us to create a much nicer, much better environment for our users to access NICIS resources. But if you are doing this with staff within NICIS that have the expertise to be able to build out this cloud platform, to do these customizations, you start building credibility within the organization to be able to go out and partner with other institutions within the country. Obviously, government comes to mind, working with government to build platforms for government services makes sense. But ideally, what happens is that you partner with the private sector. And you say there's a pool of resources, expertise within the country that we can use to build products to create what you can call sovereign clouds for South Africa. Sovereignty is especially important for government, but in general, you don't see much in the way of sovereign cloud platforms for the private sector, and potentially there's an opportunity over there. But whether it's with the private sector or with the public sector, for NICIS itself, something that we really need to be looking at is the generation of new revenue streams, because our funding does not go up as much as we would like it would. So we need to be looking at finding alternate ways of generating income so that we can fund this national research infrastructure for the users. And this is another opportunity for us to do that. It's just another way that we can generate more funding, and it would be done by reusing teams that are already building infrastructure that is related to the work that or the services that we need to deliver. So there's some synergy over there. So those are the basic opportunities and why I would like us to be moving more heavily in this route and making this kind of investment in building out a localized cloud platform. So just to give you some basic information on what that is, the first thing is when in my mind I think of a localized cloud platform, the technology actually isn't that important. You can get open source software, it's just you need to decide what is the framework, what's the basic way you've packaged this, and agree that that's the standard. The part that you really need to localize are the skills. It's the team that supports it. Because while you can get the software, open source software from anywhere, the people that support it need to be locals for it to actually be a localized cloud platform. So the guiding principles is basically it's a cloud built to our standard that is hardware agnostic. We want to use open source software as much as possible, avoid vendor lock-in with the intention of retaining sovereignty, and the actual technology stack that we've chosen, it's very aligned with what Stack HPC has been doing in our deployment of the Cape Town zone, which in Cape Town it's OpenStack KOB. In the localized cloud platform, what we've started with is Cola Ansible for OpenStack, Ceph for storage, and Bifrost for provisioning, which if you put together and put an abstraction layer on top of it is KOB. So it's very similar to what is already running in the production side of things. And then we do configuration management with Ansible. So this is a set of tools that anybody that's done anything with OpenStack will be very familiar with. They know it exists. It's nothing obscure about this. It's more about building a team of people that understands it well enough such that they're able to architect, deploy, and then support those clouds. So what we then did was we procured hardware, and this hardware it's been around for a while now, I'm not going to lie, but it's the development of the skills that has been important. We've been using this hardware to deploy what will be a new zone of Saboa in Pretoria. It's small. I think it's about a third of the size of the Cape Town cloud. Essentially, it's just one rack. It's been deployed by NICIS staff using that software stack on the previous slide, and it will be made available to the community for use early next year. There are a few caveats about this cloud environment. It is still our training wheels, so it doesn't come with a full SLA. It's going to come with as a best effort service, which means you should not be using this cloud platform for any critical jobs. You should be using it for low-risk jobs. You know, if you're going to do development, or if you need access to a very large number of VMs cheaply, or not very large, it's not a very big cloud, but if you need access to more VMs very cheaply, and you can tolerate potentially downtime as we figure things out, potentially you can use it as a site for high availability if you want to test that out between Cape Town and Pretoria. It's also potentially going to be the cloud platform that is more flexible. That is our intention. We have a set of development clouds where we can test things out and move things from development through QA and into this cloud platform in Pretoria. So it's something that will be available to you soon. It actually is deployed. The only thing that's missing is network connectivity. Once it's been given its public IP block and been connected up to the network, public internet, we'll be able to just do that last bit of configuration and then make it available. So that's going to be quite nice that we have that new zone available. This does not necessarily stay as this static software configuration. We are working on that Cola Ansible, Ceph, Bifrost environment, but that doesn't mean that we are absolutely married to it. As I say, this is a learning experience, and once we're at the point where we feel as though we are capable of running a full production service with a full SLA, we will need to think about how we move forward and harmonize all the cloud environments within NICIS. But that's something for a later stage. But what we are working on in the near term is what we should add next into the cloud platform. On the hardware front, in the development environment, we've been testing GPUs for a while now. GPUs are always in massive demand, and it's one of those things where it's actually technically very easy to add to a cloud environment. The problem is getting the GPU and then defending that GPU within NICIS, because everybody wants them. On the hardware front as well, potentially looking at higher performance networks, adding in support for InfiniBand devices, so if you are trying to build small clusters within the cloud, you get better into virtual machine performance, because the network is one of the big bottlenecks. On the OpenStack front itself, additional OpenStack services can be added in. The two that I'm most keen on is Ironic and Manila, Ironic being the bare metal provisioning service, so that if you do want to build very high performance virtual machines, or not virtual machines, bare metal machines using the cloud, you could deploy that via Ironic. Manila, that's the shared file service. So once again, if you are building a cluster of computers in the cloud that need to access a shared file system, instead of you manually setting up some kind of NFS share and then manually managing that within your cluster, you just use Manila, which will provide you with a shared file system. You can see I'm from the CHPC because my mind immediately goes to the HPC applications in cloud. Less HPC side of things, something that is always popular is getting some kind of container orchestration service up and running within these environments. Kubernetes is the obvious one that comes to mind. But these are all on our pipeline in the development environment that we'll be looking at over the next year or so. But this could be, according to you, the users, which are, while we do all of this, the wrong direction to be going in. So if there's something that you think would be particularly useful within our cloud environment, I'd like to hear from you. So I'll end with that and say thank you. Questions, requests? Yeah.
Yes, I'm just wondering if you are aware of the youth block
Yeah.
system. I don't know if you've tried to cooperate with them, and also connected to that, if you know about the plans of installing a large data system in Cape Town to deal with data from the NSA telescope, like data vision center, which will be
So it's just starting with Elifu. So I am aware of them. We've had people that have even contributed to that project. Teresa itself has had a lot to do with Elifu as well. The kind of federation that I'm talking about with the NICIS is far tighter, so we want to actually have it as like a multi-zone deployment of OpenStack eventually. But the idea of, what the first keynote from this morning, essentially, having federated access to research infrastructure within the country, I think that's a good way to go. I'd like to see that. When it comes to federating cloud platforms, the model that I kind of look at and I think is a really good one is the Australian-New Zealand collaboration, Nectar. They have a really nice solution over there. I think it could be done. The difficulty with federating with another entity's cloud is always consistency with regards to, it's a basic thing. It's like, do you have the same flavors? Can you make it such that when you deploy this virtual machine in that environment, you get the same experience no matter where you deploy it? It's not a technical problem, it's a political problem again. But I'm very open to the idea of federating the cloud platforms. And within NICIS, there is a project regarding identity management that's being run by Teresa to try and get some of our services connected up in such a way. And hopefully that will be something that can then be used to allow us to federate with Elifu as well. The intention is to enable Sapphire authentication within cloud environments within the next couple of years. That's like the most basic level of federation that we can do. As for large data platforms, so that's mostly Teresa infrastructure, which is located in Pretoria. So they have their RODS cluster, which is around, I think it's around 2 petabytes of usable storage, 4 petabytes raw, and then the long-term archive, which is 20 petabytes. Those environments have a way of ingesting data in from the Cape Town data center where the HPC cluster is involved. But this is where I talk about actually making those services more tightly integrated with the cloud environment, because right now they're kind of separated out. I would like to bring those in as a dedicated provider network directly into the OpenStack environment, and then create some kind of a service such that you could pull out that resource from inside your project within OpenStack or whatever it is. But the provider network thing I think we could do fairly easily, but the actual starting to develop more customized projects for OpenStack, that's something that's a bit more out of the way for us at the moment. There's so much that we can do, it's just like, where do you start? Yeah. Any other questions? Yeah, thank you.